Suprabhat. Today we are going to learn about distance formula. Take a point, any point, suppose it is 5, 6. Five, 6, A, and there is another point, it may be 3, 1. Now we want to find the distance between these two points. Let's join 5, 6 and 3, 1. We have joined. Now let's draw a line parallel to x-axis. Draw a line parallel to y-axis through point A. Now, as these lines are parallel to x and y axis, angle made by these two lines, that is line BC and AC, will be right angle. At this point, it will make right angle. Can you guess about the coordinates of point C? What could be its y coordinate? As it is on line parallel to x-axis, its y coordinate is constant 1, 3. Its y coordinate is 3. Its y coordinate is 3. And this line is parallel to y-axis, therefore its x coordinate is 5. So, parallel to y-axis, x coordinate is same, and parallel to x-axis, y coordinate is same. Now, can you find the distance between these 2 points? Yes, we can find the distance between these 2 points. There is an activity in your textbook as CB parallel to x-axis, y coordinate of B is equal to, parallel to x-axis, it is 3, and AC parallel to y-axis, therefore x coordinate is 5. Now we have learned to find the distance between AC. 5 is same. What is this distance? This is 6 minus 3. So, AC is equal to, suppose this is x1, y1, this is x2, y2. AC is equal to y1 minus y2 is equal to 3. And BC is equal to x1 minus x2 absolute value. Y1 is equal to what? 6. And here 3 is equal to 3. And here x1 is equal to absolute value. It is always absolute value. x1 is equal to 5 minus 1 is equal to 4. Now if it is 4 and it is 3, can you guess about AB? Now in right angle triangle ABC, angle B is equal to 90 degree. Therefore AC square is equal to AB. Angle B is equal to angle C equals to 90 degree. Therefore, AB square is equal to AC square plus BC square. That is equal to, what is AC? It is 3 square plus 4 square. That is equal to 9 plus 16, which is equal to, carrying this, AB square is equal to 25. Taking square root, AB is equal to 5. So, in this way, by using Pythagoras theorem, we can solve the activity given in our textbook. You have to fill the activity from your textbook. Okay, write down this also. Now, instead of taking numerical values for A and B, we are going to generalize the concept of distance between any two points. Take any two points. Suppose I take here A and here B, and I want to find the distance between AB. Let's join AB. We can take in any manner, as we are going to use modulus for the distance. We can take it any manner. Okay. Now again, suppose this is x1, y1, and this is x2, y2. We can see that x2 is bigger than x1, but y2 is smaller than y1. Again, same method. Draw perpendicular. Or draw lines parallel to xy axis through the points A and B as per requirement. We can take in another manner also. Okay. So, this point is C, suppose. What are the coordinates of C? Here, its x coordinate will be same. So, here it will be x1 and it will be y2, x2, y2. So, distance AC is equal to modulus of x1 minus y1 minus y2. And distance BC is equal to modulus of x1 minus x2. And in right angle triangle, as these are lines parallel to x and y axis, at point C, angle C is 90 degree. So for triangle, in triangle ABC, angle C is equal to 90 degree. Therefore, AB square is equal to AC square plus BC square. Now, as square of all negative or positive number is same, we can neglect this modulus sign. That is equal to y1 minus y2 bracket square plus x1 minus x2 bracket square, or AB is equal to square root of y1 minus y2 bracket square plus x1 minus x2 bracket square. Will it make any change if I take here y2 minus y1 and x2 minus x1? No, because there is modulus sign. Okay. Also, it will also does not affect if I take here y1 minus y2 and here I take x2 minus x1. It will not affect the value, because here we know that modulus of x1 minus x2 is equal to modulus of x2 minus x1. Both are same. Or here also modulus of y2 minus y1 is equal to modulus of y1 minus y2. It does not change. Today we will solve some examples. from exercise. Solved examples are also there. You can solve them. Okay. Verify whether the points 6 comma minus 6 Q 3 comma minus 7 and R 3 comma 3 are collinear. Let's check whether these points are collinear or not. This can be done by two ways. Graphical method is there. Draw the graph and plot the points and find whether these are collinear or not. But every time it is not possible to draw the graph. If the coordinates are bigger one, we cannot use the graphical method, and therefore we need another method. What do you mean by collinear points? We mean collinear points means that is sum of the two distances is equal to third distance. PQR can be collinear if PQ plus QR is equal to PR, or PR plus QR is equal to PQ, or PQ plus PR is equal to QR. If any two segments joined use the third segment, we will say that these are collinear points. Let's find the distance first. So, according to distance formula, PQ is equal to, this is x1, y1, x2, y2, x3, y3. PQ is equal to square root of x1 minus x2 bracket square plus y1 minus y2 bracket square, that is equal to square root of 6 minus 3 plus minus 6 minus 7. Look, here there is double bracket square, that is equal to 6 minus 3, 3 square plus bracket minus 6 plus 7 bracket square root of 9 plus 1 square 1 square root of 10. What could be the second distance? Distance QR is equal to square root of x2 minus x3 bracket square plus y2 minus y3 bracket square, that is equal to square root of x2, 3 minus 3 bracket square plus minus 7 minus 3 bracket square, that is equal to, this is 0 and this can be directly also done. Minus 3 is same, therefore distance will be minus 7 minus 3 modulus, that is equal to 0 plus 10 square, that is equal to distance QR is equal to 10 or square root of 100. Now what is distance PR? Let's find. Distance PR is equal to square root of x1 minus x3 bracket square plus y1 minus y3 bracket square, that is equal to square root of, what is x1? 6 minus 3 plus minus 6 minus 3 bracket square, that is equal to, this is 3 square plus, this is minus 6 minus 3, it is minus 9 bracket square, that is equal to 9 plus, what is square of minus 9? It is plus 81, square root of 90. Now, though it will look that square root of 90 and square root of 100, we will see the numbers as. We can see that the sum of the numbers inside the radical sign is 90 plus 10 can be 100, and just by looking we can say that these points are collinear, but it is not so, because we know that what is square root of 10? It is something 3.1 like that. What is square root of 10? Root 10 is equal to 3.1 to 3.19 it is. What is square root of 90? That is equal to 9.4, and square root of 100 it is 10. Now can we say that distance PQ, these are the smaller distances, this is the bigger distance. Can we say that 10 is equal to 9.4 plus 3.19? Can we say? No. And 10 is not equal to 9.4 plus 3.90. Therefore, we have to write that distance PQ plus distance QR is equal to root 10 plus root 90, and distance QR is equal to 100. Distance QR is not equal to distance PQ plus distance QR PR. And therefore PQR